right, hello everybody. Welcome to today's live stream. My name is Tyle. I'll be the teacher today. So welcome back to those of you who have been to previous sessions. Thanks for joining us. Today we're going to be talking about degrees and radians and how to convert between the two. As we go, feel free to type questions into the YouTube chat. And our lovely moderators, especially Shadna, will be passing those questions along to me. All right. Also, please make sure you have a paper and pencil with you so you can follow along as we go. Let's start with a quick warm-up. Please convert the following measures from radians to degrees or vice versa. If you don't know how to do these, well, you've come to the right place. I will teach you. But for those of you who do have some familiarity, you can warm up by trying some of these. I'll give you about a minute, which may not be enough time to finish, which is okay. Okay, I would guess that most of you probably have not finished unless you're already a super expert on converting these. Anybody who's joining after the fact, feel free to pause the video and spend some more time if you would like. But I'm going to dive into teaching the lesson. First, let's review some circle terms. The first one that I want to mention is the radius, which is a line from the circle's center to any point on its edge. So I'll draw another radius like this. So these two blue lines are both radii, we say. And these two radii define an arc, which is a section of the circle between 2 points. Okay, so along the outside of the circle, we have an arc like this. And we say that the length of the arc is the arc length, right? Somewhat creatively named, yeah. So length of arc equals the arc length. Next, we have an angle, which is defined by these two radii here. So we have the angle that I've drawn in purple. And as a bit of terminology, we say that the angle is subtended by the arc. So we can write arc or an arc subtends an angle. Okay, so in this case, the purple angle inside the two radii is subtended by this red arc. All right, just a term you may hear. And then finally, the point where the two radii come together, the two arms of an angle in general, where those come together is called the vertex of the angle. Okay, so just some basic terms about a circle that I may be using as we go through the next few slides. So now let's talk about how to measure angles. The way that we do this is to define standard units, which means an angle of a fixed size that we can compare other angles to. And one of the most common is a degree. So here's a picture. So a degree is this small sliver of a circle. There are 360 degrees in one full circle. So each degree is 1/360th of a circle. So if we had some other angle, say like this one on the right on the slide, defined by these two red radii, To decide the measure of the angle, we could count how many degrees it takes to make the angle. So I could start counting how many degrees this is. I could say maybe that's 1 degree, 2 degrees, 3 degrees, 4 degrees, etc. Okay, dot, dot, dot. Count how many degrees are in here to determine the measure of the angle. This is the same way units work in general. For example, like when we say something is 2 meters long, there used to be this bar in a vault in Paris that was by definition 1 meter long. And so saying something was 2 meters meant you would lay the bar twice across the face of the object, and then the object would be 2 meters long. Same thing with degrees. We're just counting. Meters are done differently now, not with the bar. But that's just an example. So radians are a similar idea. Another common standard for angle measurement. Instead of 360 degrees, there are instead 2 pi radians in one full circle. Okay, that's a key thing to remember. 2 pi radians in a full circle. Since pi is a little more than 3, that means there are a little more than 6 radians in one full circle. And so I've put in a picture here below showing you about how big 1 radian is. Okay, just to help you with visualizing this. And let's say we had some angle that we want to measure in terms of radians, like the one that I've put on the right. Maybe I want to know how many radians are in the little blue arc that I just drew. And the way we could do this is just count how many radians. So maybe this is 1 radian, and then maybe this is another 1 radian. So then it looks like, let's just call this 0.1 radians there. So then we'd say that this whole arc is about 2.1 radians, just eyeballing it. Okay, so then how much would be left over for the rest of the circle? So if the top arc is about 2.1 radians, then how much is left over for the bottom? Well, if the full circle is about 6.3 radians, then the bottom down here is about 6.3 radians minus the 2.1 radians that we saw up top, or a bit over 4 radians. Okay? So that's the basic idea of degrees and radians. If only life were always that easy. Unfortunately, sometimes problems give us measures of angles in degrees, and we need to convert them to radians, or vice versa. But first, let's see how to convert degrees to radians. The first thing to note is that 1 full circle equals 2 pi radians, we said. Right? There are 2 pi radians in a full circle, but there are also 360 degrees in a full circle. So this means that 2 pi radians equals 360 degrees. Or we could simplify this by dividing both sides by 2. And so I could say that pi radians equal 180 degrees. Okay? And we can use that to convert between radians and degrees. So let's start with an example. Let's say that we're given, 30 degrees. And we would like to convert this to radians. So here's how we could do it. I want to multiply 30 degrees by pi radians divided by 180 degrees. Notice that since pi radians equals 180 degrees, when I multiply by this ratio that I've just circled, this is just like multiplying by 1. In fact, this is just multiplying by 1, since the numerator and denominator are equal. So I'm not changing the value of 30 degrees, but multiplying by this ratio will allow me to convert from degrees to radians. I've been careful in putting radians on top and degrees on bottom. The reason to do that is that with degrees on bottom, the degrees cancel out of this fraction when I multiply, leaving me with units of radians. And similarly, the 30 here sort of cancels with the 180 to simplify to 6. So then all in all, when I do all this out, I get equals pi over 6 radians. Okay, I'll do another example. Let's say instead of 30 degrees, I don't know, we have 90 degrees. All right, what should I do next? I have 90 degrees. I want to convert degrees to radians. Okay, so I'll use that half a turn of a circle is both pi radians and 180 degrees, like I did before. So I'll multiply by that same ratio. Pi radians divided by 180 degrees. Okay, multiplying by that same ratio. And just like before, we have degrees here, which cancels with degrees in the denominator of the fraction, leaving us with radians. And the 90 and 180 also partly cancel. So the 90 divided by 180 just becomes 1/2. So in all, we have pi over 2, because don't forget the pi that was in the numerator. And the degrees canceled, so we just have pi over 2 radians. Okay, so 90 degrees is pi over 2 radians. All right, and let me do just one more as an example to make sure that everybody fully has this. I'll just say 45 degrees. And again, I will multiply by pi radians divided by 180 degrees. Okay. The degrees will cancel, just like before. And 45 divided by 180, well, 45 times 2 is 90, times 2 again is 180. So then overall, this gives me pi over 4 radians. Okay. And I would also like to draw a quick picture of each of these, just to help people visualize. So first, here's pi over 6, which we said was 30 degrees. So that's an angle that's about this size, about a third of a right angle. Next, for 90 degrees, here's a picture of a 90-degree angle, or pi over 2 radians angle. And finally, a 45-degree or pi over 4 angle is half of a right angle. Okay? All right. Let me know in the chat if you have any questions, but this is how we convert from degrees to radians. Now, let's do it in the opposite direction. Sometimes we are given radians and we need to convert them to degrees. We can still use a very similar process and the fact that pi radians equals 180 degrees. We just multiply by the ratio flipped. Okay, we multiply by pi radians divided by 180 degrees instead of vice versa. So let's see a few examples of this. Okay, let's convert some radians to degrees. Let's start with, I don't know, 3 pi over 2 radians. Okay, so what should I multiply by? I want to choose a ratio where the radians cancel. So I'll put degrees on top, 180 degrees, divided by pi radians. Okay, and we can see that now the radians cancel. And so do the pi's, right, from the numerator and denominator. So now I just have 3/2 of 180. And so this is 3/2 times 180 degrees. And 3/2 of 180 is 270 degrees. So I see we have a question here. So somebody asked, does pi radians divided by 180 degrees apply to all problems when converting from degrees to radians? Yes, that's a great question. And yes, you can always use pi radians over 180 degrees. Yep, that will always work. Some people like to use some different sort of conversion. So there are other possible ways to do it, but you always can use pi over 180. Yep, and that's my favorite way. So I'd recommend it because it always works. And somebody else says, all your seminars are really helpful. Oh, well, thank you. And somebody says, thank you so much for organizing them. Yeah, you're quite welcome. I enjoy doing them, and I'm glad that people find them helpful. All right. Let me do one more. Let's say that we have maybe even two more. Let's say we have pi over 3 radians. Okay. So what should I multiply this by to convert to degrees? Same as before, I want the radians to cancel. So I want the degrees on top and radians on the bottom. Right? I want to make sure that I put the radians in the denominator so that it cancels, because I'm trying to get rid of the radians and end up with degrees. And like above, the pi's also cancel, because we have pi on the top, pi on the bottom. So we're left with 180 over 3. Okay, and 180 over 3 is 60 degrees, since that's the unit that didn't cancel. And I'll do just one more. What should I do here? Sure, why not? I'll do 2 pi over 3 radians. So notice this is similar to the numbers we had before. It's just twice as big as pi over 3 radians, so I'm expecting to get 120 degrees since that's 2 times 60. But I'll still just use this same process, 180 degrees divided by pi radians. Okay, and as usual, it looks like the pi's cancel. The radians also cancel. And so in the end, I have 2/3 of 180 degrees. And that is indeed 120 degrees. 2 times 180 is 360. Divided by 3 is 120. Okay. And again, I will just draw some pictures to show what these various angles look like. So here is a picture of what 270 degrees, or 3 pi over 2 radians, looks like. And it's this outside angle, the big one. Okay, 3/4 of a circle. Next, I'll show you what 60 degrees looks like on a circle, or pi over 3 radians. It's 2/3 of a right angle. And finally, 120 degrees is 30 degrees more than a right angle. So this is what 2 pi over 3 radians would look like. Okay, and a reminder, feel free to ask any questions as we go. So just a couple of notes about notation. Instead of writing out degrees, people often use the degree symbol, this little circle, which is placed up near the top of the number to its right. So instead of writing out 30 degrees, somebody may instead write 30 with the little degree symbol that I've made here, and these two mean the same thing. There we go, that's what I'm trying to do. So there's the little degree symbol. So 30 degrees just written in two different ways. Instead of writing out radians, people may just write RAD, rad, as an abbreviation, or sometimes people just don't write anything. They just write the number. So here's an example. This is especially true when the angle is inside of some function. So if the angle is acting as the so-called argument of a function, people may not write radians even though they really mean radians. So for example, here we're taking the sine of pi over 6. And so pi over 6 what's? Is that supposed to be pi over 6 degrees? Is it pi over 6 radians? Which one? What do you think? Did the person who wrote sine of pi over 6 mean degrees or radians? They meant radians. The way I can tell is if it's not written, by default, it might mean radians. If it's not written, you need to assume it means radians rather than degrees by default. But that said, if you're not sure, you can always just ask your teacher. Okay. Another good rule of thumb is like if there's a pi in it, likely to be radians. But again, if you're unsure, you can always just ask your teacher. So here's a quick reason that radians are kind of cool. They make equations simpler. Don't worry if you haven't seen calculus yet. This is just an example of a common equation that you may learn in either your pre-calculus or calculus class. It says that the derivative of sine of x equals cosine of x. So that's nice. Pretty simple equation. But this equation is only true if x is in radians. Okay, x has to be in radians for that formula to work. If x were in degrees, the formula instead would have this extra conversion term that we would need to include. Gross. So instead, people just assume that x is in radians, and then we get the nice simple formula on the left. Okay, without that pi over 180 conversion factor. Here's another example. In this formula, S means arc length. R is the radius of the circle, and theta is the angle subtended by the arc S. Okay, this is a nice simple formula. But once again, it only works if theta is in radians. If theta is in degrees, we would have this more complicated formula that I'm highlighting, or whoops. There we go, that I'm highlighting here. Okay. If theta were degrees, it would be more complicated. And let me just draw a quick picture as well to remind you, or to sort of help show you what this equation is saying. So if we have some circle here, and let's say that we have two different radii, each of which has length r, as shown in the formula, then the arc length I will draw in purple. Okay, so here's the arc length s. All right, and the angle in between we're calling theta. That's a Greek letter that looks like an O with a little line through the middle. Okay, so that's just another equation that for it to be true, theta, the angle, has to be measured in radians. And then finally, another formula that you might see in pre-calculus. This is called Euler's formula. E to the I theta equals cosine theta plus I sine theta. Don't worry if you haven't seen this yet, but if you have, keep in mind this only works if theta is in radians. Otherwise, once again, we would need to include a conversion factor in the exponent, this pi over 180. All right. And good question from Vazvi, who asks, can we write a small c on top for radians? Yes, you can. That's a bit less common, but sometimes, depending on your teacher or which book you're using, you can draw a little c instead of the degree symbol to indicate radians. Absolutely. Good question. Radians and degrees are not the only ways to measure angles, but they are by far the most common. Just for fun, I wanted to quickly mention a couple others. There are some measures called gradients. A gradient is 1/100th of a right angle. These get used by surveyors, especially in Europe, as well as in geology a little bit. These are also called gons or grades. So there are 400 gradients in one full circle. People use turns sometimes, or also therefore centiturns or milliturns, which mean 1/100th or 1/1000th of a turn. So there would be one turn in a circle. So one turn would equal 2 pi radians, or there would be 1,000 milliturns in a circle. And then in the military, often for especially like artillery, scopes, things like this, or compasses that you want to be extremely accurate. There are a whole bunch of different types of units that get used, like NATO mils, Warsaw Pact mils, the Swedish streck. So that's pretty cool. The idea there is that you can achieve a higher resolution than with a 360-degree scope, while also keeping it easier to divide into parts than if you were to use, say, thousandths of a radian. Okay, don't worry about that too much. Just letting you know that there's a whole bunch of cool different units out there. Um, but usually, almost all of the time, we stick with degrees and radians. So now that we've gone through and learned how to do these, take another minute. I'll give you guys like 30 seconds to get a quick head start on me, and then I'll quickly go through and we can do these 10 together. Also, as we're wrapping up, let me know if there are any final questions you guys have in the chat. Okay, so I'll give you just a second to get a quick head start on some of these if you want, and then we can go through and do them together. All right. So I see that one of the questions that just came through in the chat was, so for converting radians to degrees, could we multiply the top number of the fraction, that is the number next to the pi, by 180, and then divide the number that that gives you by the number on the bottom of the fraction? Yes, that's a great question. And that does indeed work if we assume that the number has the following form. So if the number is like 2 pi divided by 3, then I think what the questioner is asking is, could we take this number, the 2 that I just circled, multiply this times 180, and this would give us 360. And then questioner is saying, let's divide by the 3. Okay, divide by the 3, so we do divided by 3, and this would give us 120. And yeah, this does work as long as the number has this form with a number multiplied by pi divided by some other number. I think it's easier for a lot of people to remember just to always use, and this is in radians, to always use the procedure that we had seen where it's 180 degrees divided by divided by pi radians. There we go. Pi radians. And notice that this works out the same way because in both cases we get rid of the pi. In one case we just kind of dropped it, and in the other case we're explicitly dividing by it. And then we are multiplying the 2 by the 180, right, in both cases. and dividing by the 3. So they work the same way. I think that the one that I'm about to put a box around, I think this is a good way for most students to remember what's happening. It'll also make your work clearer to your teacher, but either one of these does work. So that was a really good question, and either one would work. Somebody also asked, in the slide, radians are cool. Could I explain the last formula again? Like, what is E and I and where is it used? Yeah, absolutely. Let me actually circle back to that, though, after going through these first 10 questions. And then I'll stick around for a few minutes after the presentation to give a little bit of bonus answers about E and I and stuff like that, just because that's a little bit of a separate topic. All right. Keep the questions coming, though. Those were both great. So like before, we want to convert from degrees to radians. So I'm going to multiply by one of these ratios. Oh, somebody asked, is the volume broken? So I hope that people can hear me. I hope that it's not like super loud or super quiet. Keep comments about that coming into the chat if so. So yeah, 360 degrees. Oh, it's perfect. Okay, great. So 360 degrees, I want to convert to radians. So I want radians on the top, pi radians, and that equals 180 degrees. Okay. And like we've seen previously, the degrees here cancel. Okay. And so we get 360 divided by 180, which gives us 2. So this is 2 pi radians. All right. And let's do this next one. This time, we're already in radians. So I want to multiply by 180 degrees divided by pi radians. And the radians cancel. The pi's also cancel, leaving me with 180 degrees. All right. Next, we have 90 degrees. So if we have degrees, then I want to multiply by radians on the top, degrees on the bottom. So times pi radians divided by 180 degrees. All right. And so the degrees cancel, and we get 90 divided by 180, which is a half. So this gives me pi over 2 radians. Okay. Pi over 3 radians. So what should I multiply by this time? Okay, well, I want to end up with degrees. So I want to do 180 degrees divided by pi radians. And the pi's here cancel. Okay, and the radians cancel. So I end up with 180 divided by 3, which is 60 degrees. I'm going to skip these middle few. And if people have questions about them, then we can come back. But I'll skip 5 through 8 and leave those as exercises for you. And let me just finish up with 9 and 10. So 1 degree, if I want to convert to radians, I want to multiply with radians on the top times pi radians divided by 180 degrees. And like before, or like usual, the degrees cancel. And so we get that 1 degree equals pi over 180 radians. Okay, and 1 radian times 180 degrees over pi radians equals, the radians cancel. Okay, and so we get 180 over pi degrees. And 180 over pi is about 57 degrees. All right, I skipped the middle few just because I was getting tired of doing them, and so I figured that some of you might be getting tired of doing them also. All right. So yeah, thank you so much for joining us. Let me quickly now just go back and answer the question about um, e to the I pi. Maybe actually this is a little bit too much to explain in a short time, but the idea is that we have something called the complex plane, and we can raise complex numbers on this plane, or we can use them as exponents. And there's a formula which relates exponentiation of a complex number to the result of that operation, and that's called Euler's formula. And it's the one that I'll highlight in blue here, or whoops. The one that I will highlight in blue, I say. Yes, there we go. That's this formula. And it's a nice, pretty formula, and that's great. You'll learn more about this in pre-calculus. But this formula only works if the angle theta in the formula, which appears in the exponent here and also as the arguments of the sine and cosine functions, theta has to be in degrees for this formula to work. All right. And again, you would just learn more about this formula and what it does in pre-calculus. But all right, yeah, that is radians in degrees. So if there are no final questions, hopefully now you know how to convert from radians to degrees and back again. And yeah, thanks again for joining us. I'll see you again in a week or two.